Welcome to the Leap into Finance YouTube channel, where we offer insights, tools, and resources to help finance professionals advance their careers. Now let's dive into today's topic, time value of money, TVM, in the CFA Level 1 curriculum. Time value of money is an essential concept in finance that explains how the value of money changes over time, primarily due to interest rates and inflation. In this video, we'll explore the deeper intricacies of TVM, focusing on tricky areas you need to master for the exam. You're probably familiar with the basics, so we'll highlight more advanced topics and provide worked examples using the Texas Instruments BA2 Plus Professional Calculator to help you prepare. Quick recap, the basics of TVM. At the core of TVM, the main idea is that money today is worth more than the same amount in the future due to its potential to earn interest. The basic formula to calculate the future value, FV, of a sum of money is future value equals present value times 1 plus the interest rate raised to the power of the number of periods. In symbols, FV equals PV time 1 plus R raised to the power of N, where FV is the future value, PV is the present value, R is the interest rate per period, N is the number of periods. Now that we've brushed up on the basics, let's dive deeper into the tricky areas that could appear on your exam. Tricky areas of TVM. 1. Compounding frequency, quarterly versus monthly. In many cases, interest is compounded more frequently than annually, such as quarterly or monthly. You must adjust both the interest rate and the number of periods accordingly. Let's take a look at a worked example using quarterly and monthly compounding. Example: future value of $1,000 invested at a 6% annual rate, compounded quarterly for 5 years. For quarterly compounding, follow these steps. The annual nominal interest rate is 6%. The interest is compounded quarterly, so divide 6% by 4 to get 1.5%. The number of periods is 5 years, times 4 quarters per year, so you have 20 periods. Using your BA2 Plus calculator, press second then I/Y to set the interest rate per period. Enter 1.5. Press N and enter 20 for the number of periods. Press PV, enter minus 1,000, negative because it's an outflow. Press PMT, enter 0, no payment during the investment period. And press CPT then FV. The future value is 1,346.855. Now let's calculate the future value for monthly compounding. Divide the annual nominal rate of 6% by 12 to get 0.5%. The number of periods is 5 years times 12 months per year, which gives 60 periods. Using your calculator again, enter I/Y equals 0.5. Enter N equals 60. Press PV equals minus 1,000. Press PMT equals 0, CPT then FV. The future value is 1,348.850. Notice the slight difference due to compounding frequency, so always double-check the compounding period and interest rate adjustments on your exam. 2. Effective versus nominal rates. Nominal rates are the stated annual rates without considering compounding, while effective rates account for how often compounding occurs during the year. Let's work through an example where you need to calculate the effective annual rate, EAR, from a nominal rate of 12% compounded monthly. The formula for EAR is EAR equals 1 plus the nominal rate divided by the number of compounding periods, raised to the number of periods minus 1. For 12% compounded monthly, nominal rate R is 12%. Monthly compounding means 12 periods per year. Now plug this into the formula. EAR equals 1 plus 0.12 divided by 12, raised to the 12th power, minus 1. This gives you an EAR of 12.68%. This is important because the effective rate accounts for compounding within the year and will be higher than the nominal rate. 3. Inflation adjustment. Inflation decreases the purchasing power of money over time, so we must adjust for it to calculate the real interest rate. Use the Fisher equation to adjust for inflation. 1 plus nominal rate equals 1 plus real rate times 1 plus inflation rate. To solve for the real rate equals 1 plus nominal rate divided by 1 plus inflation rate, minus 1. For example, if your nominal rate is 5% and inflation is 2%, the real rate is equals 1 plus 0.05 divided by 1 plus 0.02, minus 1. This gives you a real rate of 2.94%. So, even though the nominal rate is 5%, inflation reduces the actual purchasing power, and you only effectively earn 2.94% after inflation. 4. Annuities. Annuities are payments made at regular intervals, and there are two common types: ordinary annuities and annuities due. Ordinary annuity example. Let's calculate the future value of an ordinary annuity, where you receive $200 per year for 5 years at an interest rate of 8%. Using the formula for future value of an ordinary annuity, FV equals PMT times 1 plus R raised to the power of n-1 divided by R, where PMT is the annual payment, R is the interest rate per period, N is the number of periods. In this case, PMT equals 200, R equals 8%, and you get some. Using your BA2+, enter PMT equals 200, enter PV equals 0, enter N equals 5, enter I/Y equals 8, press CPT then FV. The future value is 1,173.32. Annuity due example. Now for an annuity due, the payments are made at the beginning of each period. To find the future value of an annuity due, the calculation is similar to the ordinary annuity, but multiplied by 1 plus R to account for the early payment. Let's calculate the future value for the same $200 payments, but now as an annuity due. On the calculator, press second then BGN to switch to annuity due mode. The rest of the inputs remain the same. The future value is 1,267.186. 5. Perpetuities. A perpetuity is a series of payments that continue forever. The present value of a perpetuity is calculated using this simple formula. PV equals C divided by R, where C is the payment per period, R is the interest rate. For example, if you receive $50 per year forever and the interest rate is 5%, the present value of this perpetuity would be PV equals 50 divided by 0.05. This gives a present value of 1,000. It's crucial to recognize when you're dealing with a perpetuity, as it has a different calculation than a regular annuity, and this can be a tricky point in exam questions. By mastering these advanced concepts and knowing when to adjust for things like compounding frequency, inflation, and payment timing, you'll be well prepared to handle the more complex time value of money questions on the CFA Level 1 exam. Keep practicing with your calculator, and make sure you're comfortable adjusting the inputs for different scenarios. Thanks for watching. If you found this video helpful, make sure to hit that like button and subscribe to the channel for more insights on finance certifications, exam tips, and career success strategies. Want to level up your preparation? Check out the links below for some hand-picked resources available on Amazon that can help you ace your exams, including our very own Leap Into Finance notebook designed to keep you organized and on track. And if you're looking for more than just study materials, visit leapintofinance.com for scholarships, job opportunities, and exclusive career resources. Got any questions or feedback? Drop them in the comments below. We'd love to hear from you. And be sure to check out the videos on your screen for more valuable content to support your finance journey. Stay focused, stay determined, and keep leaping into finance.